Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that this angle BAC of triangle ABC equals to 60 degrees. We also know that BF equals to CF equals to DF equals to EF. Actually, those signs VF equals to DF to CF, and that equals to DF that equals to EF. So those four line segments are equal to each other, and also we know that triangle BDF, this triangle, equals to 8 square units. The area of triangle BDF equals to 8 square units, or the area of triangle BDF is 8 square units, and the area of triangle FEC is a 15 square units, and we want to find out the area of quadrilateral ADFE. Okay, so first of all we will define angle ABC. This angle is B, and we will define angle ACB. This angle is C, and we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, in triangle ABC, 60 degrees plus angle B plus angle C must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle equals to 180 degrees. Okay, so from this equality we will subtract 60 degrees. It will be a question number 1, and we will get that B plus C equals to 180 degrees minus 60 degrees is 120 degrees. And we also have a rule, we call it rule number 1. Rule number 1 states that in front of equal sides in the triangle there are equal angles. In front of equal sides in the triangle there are equal angles. So I will read rule number 1 again. Rule number 1 states that in front of equal sides in the triangle there are equal angles. So if we focus on triangle BDF, in triangle BDF it is given us in the questions that side BF equals to side DF, and in front of side DF we have angle B, in front of side VF we have angle BDF. So according to rule number 1, those two angles that are located in front of equal sides are also equal to each other. Therefore, if this angle is beta, the other angle, this angle must be also equal to B. If this angle is B, then the other angle must be also equal to B. Okay? And the same thing, it is true in triangle AFC. In triangle AFC, this triangle, we know that FC equals to FE. Therefore, in front of FE we have angle C, and in front of FC we have angle FEC. This angle FEC must be equal to angle C because those two angles are located in front of equal sides. Therefore, they are also equal to each other. That is to say, if this angle is C, this angle must be equal also to C. Okay? In the next step, we'll define angle DFB as P, and we will define angle EFC as Q. Then we will express angle P in terms of B, and we will express angle Q in terms of C. We know that in triangle BDF, this triangle, the sum of the angles is equal to 180 degrees. It is as it is in any triangle, so B plus B plus P equals to 180 degrees. Or 2B plus P, 2B plus P equals to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay, so this is in triangle BDF. Here we will subtract 2B from this equality, and we will get that P equals to 180 degrees minus 2B. Okay, we will do the same thing about triangle FEC. We know that the sum of the angles in triangle FEC equals to 180 degrees. That is to say, angle Q plus angle C plus angle C must be equal to 120 degrees. So Q plus 2C equals to 180 degrees. So from this equality we will subtract 2C, and we will get that Q, angle Q equals to 180 degrees minus 2C, and we also found out that angle P equals to 180 degrees minus 2B. So here we will add Q to B, and we will get that Q plus P equals to 180 degrees plus 180 degrees is 360 degrees minus 2C minus 2B here we will take minus 2 as a common factor of this expression, and we will get that Q plus P, that will be equation number 2. Q plus P equals to 360 degrees minus 2 times b plus c. Okay, but we have already found out that b plus c, according to equation number 1, b plus c equals to 120 degrees Okay, we know that b plus c equals to 120 degrees, so we can substitute b plus c in equation number 2 by 120 degrees from equation number 1. Okay, and we will get that q plus p equals to 360 degrees minus 2 times b plus c, and we will substitute b plus c by 120 degrees. So we got that q plus p equals to 360 degrees minus 2 times 120 degrees is minus 2 times 240 degrees. So we found out that q plus p equals to 360 degrees minus 240 degrees is 120 degrees, and we have already found out that b plus c equals to 120 degrees. Okay, so we have these two equations, that q plus p equals to 120 degrees and also b plus c equals to 120 degrees. Okay. In the next step, we will find out the size of angle DFE. We will find out the size of this angle according to rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. Rule number 2 states that the sum of the angles on a straight line is equal to 120 degrees. So I will read rule number 2 again. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. Okay, so according to rule number 2, actually we know that BC is one side of triangle ABC, therefore BC it is a straight line. BC is a straight line because it is one of the sides of triangle ABC. So BC is a straight line. Therefore, we know, according to rule number 2, that the sum of the angles on a straight line equals to 180 degrees. And if we focus at point F, according to rule number 2, the sum of the angles at point F along the straight line BC equals to 180 degrees. So if we focus at point F, we can write down that P plus Q plus angle DFC equals to 180 degrees according to rule number 2. Again, P plus Q plus angle DEC must be equal to 180 degrees according to rule number 2, that states that the sum of the angles on a straight line equals to 180 degrees. So here according to rule number 2, or question number 2, P plus Q equals to 180 degrees. So Q plus P equals to 120 degrees. Therefore, we can substitute P plus Q by 180 degrees according to equation number 2. So we will get that 120 degrees plus angle DFC equals to 180 degrees. So we substitute 120 degrees from this equality in order to get the value of angle DFC. We will get that angle DFC is equal to 180 degrees minus 120 degrees is 60 degrees. Okay, so angle DFC, this angle equals to 60 degrees. In the next step, we will connect together points D and E by a straight line. Actually, by connecting together points A and D, we created triangle DFC. So in triangle DFC, we know that side DF equals to side FE. Side DF equals to side FE, triangle DFE. Therefore, according to rule number 2, it states that in front of equal sides there are equal angles. In front of this side we have angle FDA, and in front of this side we have angle FED or DF. Okay, so according to rule number 2, those two sides that are located in front of equal sides are also equal to each other. So if we define one angle as Y, then the other angle must be also equal to Y. Okay, and again we know that in triangle DFE the sum of the angles is equal to 180 degrees, so we will focus on on triangle DFE. The sum of the angles in any triangle, and especially in triangle DFE, equals to 180 degrees. So actually 60 degrees plus angle y plus angle y, it is plus 2y, equals to 180 degrees. Okay, we got this equality. We will subtract 60 degrees from this equality, and we will get that 2y equals to 180 degrees minus 60y is 120 degrees. So we found out that 2y equals to 120 degrees. Here we will not divide this equality by 2 in order to get the value of y. So y will be equal to 120 degrees over 2 is 60 degrees. So angle y equals to 60 degrees, so we substitute angle y by 60 degrees. So this angle equals to 60 degrees, and here also angle y equals to 60 degrees. So actually all the angles in triangle FDC of FDE equals to 60 degrees, therefore it is an equilateral triangle, and in an equilateral triangle all the sides are equal to each other. So this side DE equals to side DF equals to side FC. Actually all the diagonal lines that I marked by 2 lines are equal to each other. So if VF equals to X, then FC also will be equal to X, and also FE equals to X, and also DE will be equal to X, and DF also equals to X. Okay. In the next step we will find out angles AED, this angle, and angle ADE, this. So we will find out those two angles according to a new rule. According to rule number 3, according to rule number 2, we know that the sum of the angles on a straight line is equal to 180 degrees. So we know that AB is one side of triangle ABC. Therefore, AB is a straight line. Therefore, we will implement rule number 2 that says that the sum of the angles on a straight line equals to 180 degrees. We will implement rule number 2 on the straight line AB. AB is a straight line. Therefore, at any point, the sum of the angles are equals to 180 degrees. That is to say, if we focus at point D, we can say that B plus 60 degrees plus angle ADE, this angle must be equal to 180 degrees according to rule number 2. Again, B plus C plus angle ADE must be equal to 180 degrees according to rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. Okay. Here we will subtract 60 degrees and B from this equality, and we will get that angle ADE equals to 180 degrees minus 60 degrees is 120 degrees minus B. Okay, we found out that angle ADE equals to 120 degrees minus B. But we have already found out in the question number 1 that B plus C equals to 120 degrees. And if we subtract B from question number 1, we will get that C equals to 120 degrees minus B. Okay, so 120 degrees minus B equals to C. So here we have 120 degrees minus B, and according to equation number 1, 120 degrees minus B equals to C. Okay, so actually from this equality we can derive that angle ADE equals to C. Angle ADE equals to C. So this angle ADE equals to C. Okay. In the next step we will do the same process on the other side of the triangle in order to find out the size of this angle. We will use rule number 2. Again, AC is one of the triangle ABC sides, therefore AC is a straight line. Therefore we can implement rule number 2 in the straight line AC. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. Therefore, if we focus on point E, C plus 60 degrees plus angle AED, this angle must be equal to 180 degrees according to rule number 2. Again, C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2 that states that the sum of the angles in a straight line equals to 180 degrees. Here we will subtract 60 degrees and C from this equality, and we will get that angle AED equals to 180 degrees minus 60 degrees is 120 degrees. and we subtracted also C, so it is 180 degrees minus C. Okay, but we know that according to equation number 1, that B plus C equals to 120 degrees. Here we can subtract C from this equation number 1, and we will get that B equals to 120 degrees minus C. So actually, according to equation number 1, 120 degrees minus C equals to B. So we can write here that 120 degrees minus C equals to B according to equation number 1. And from this equality we can derive that angle AED equals to B. Okay, angle AED equals to B. So actually angle AED, this angle, equals to B. In the next step we will prove that triangle AED is similar to triangle ABC. So we will focus on triangles ADE. And triangle ADE. Okay, we'll focus on the big triangle, triangle ABC, this small green triangle, triangle ADE. We know that angle AED equals to angle ABC, and both those two angles are equal to B. Okay, angle AED equals to angle ABC, and both those two angles are equal to B. Okay. Again, angle AED equals to angle ABC, and both those two angles are equal to B. And we also know that angle ADE, this angle, is equal to angle ACB in triangle ABC. Okay, those two angles are equal to each other, and both those two angles are equal to C. Okay, again, angle ADE equals to angle ACB, and both those two angles are equal to C. Both those two angles are equal to C. Okay, and we know that angle A that's equal to 60 degrees is a common angle. It belongs both to the small triangle, triangle ADE, and angle E belongs also to the big triangle, triangle ABC. So we can write down that angle A equals to angle A because it is actually a common angle. Okay, angle A equals to angle A, it is a common angle. So we actually proved that all the sides of the big triangle, triangle ABC, are congruent to all the sides of triangle ADE. Therefore, triangle ABC is similar to triangle ADE. Triangle ABC is similar to triangle AD. Again, triangle ABC is similar to triangle ADE according to angle similarity rule. Triangle ABC is similar to triangle ADE according to angle similarity rule. Angle similarity rule states that if all the sides of one triangle are congruent to all the sides of the other triangle, then those two triangles are similar to each other according to angle similarity rule. Okay? Actually, we have rule number 4 that relates to similar triangles. According to rule number 4, the ratio between the areas of similar triangles the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So I will read actually it is rule number 3. Rule number 3 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So actually, according to rule number 3, if we divide area of triangle ABC that is the sign of the area. That means that is the area of triangle ABC. If we divide the area of triangle ABC by the area of triangle ADE, according to rule number 4, it equals the square ratio of the corresponding sides. And the corresponding sides are BC and DE, so the square ratio is the square ratio of the corresponding sides are BC square over DE square. Okay, again, according to rule number 4, the ratio between the areas of the two similar triangles, triangle ABC and triangle ADE, is equal to the square ratio of the corresponding sides. That is to say, it equals to BC square over DE square, because BC and DE are the corresponding sides, and rule number 1 states that it is equal to the ratio of the corresponding sides. That is to say, it equals to BC square over DE square. Okay, but what is the size of side BC? The size of side BC of triangle ABC equals to x plus x according to our definition, so it equals to 2x, and BC square is 2x square over DE square. DE equals to x according to our definition, so DE square will be equal to x square. Okay, so actually the ratio between the area of triangle ABC over the area of triangle ADE equals to 2x square. 2x square is 4x square over x square. 4x square over x square is 4. So we actually found out that the ratio between the area of triangle ABC over the area of triangle ADE equals to 4. Okay, the ratio between the area of triangle ABC to the area of triangle ADE equals to 4. So if we multiply this equality by the area of triangle ADE, we will get that the area of triangle ABC equals 4 times the area of triangle ADE. Okay, actually the area of triangle ADE, that is the green triangle, is a quarter of triangle ABC, or the area of triangle ABC is 4 times big than the area of triangle ADE. Okay, so the area of triangle ABC equals to 4 times the area of triangle ADE. In the next step, we will calculate the area of quadrilateral DBCE. So the area of quadrilateral DBCE, the area of quadrilateral DBCE equals to the area of the big triangle, triangle ABC, minus the area of triangle ADE. Okay, so it equals to the area of triangle ABC, the big triangle, triangle ABC, minus the area of triangle ADE. Okay, So again, the area of quadrilateral DBCE equals to the area of triangle ABC minus the area of the small triangle, triangle ADE, the small triangle, triangle ADE. And we also found out that the area of triangle ABC equals 4 times the area of triangle ADE. Okay. In the next step, I will present to you a new formula for the area of any triangle. So if we have triangle ABC, and we know that the size of side AB is A units and the size of side AC is B units, and the angle between side AB to side AC is theta. Then the area of this triangle ABC will be equal to A times B times sine theta over 2. Again, it equals to A, the area of triangle ABC, equals to A times B times sine theta over 2. Okay. Again, the area of triangle ABC equals to A times B times sine theta over 2. Okay, we use this formula in order to calculate the areas of those two triangles. Actually, if we divide the area of the big triangle by the area of the small triangle, we will get that 15 over 8, it is 15 square units over 8 square units. So what is, we got the ratio of 15 over 8, and so the area of triangle FEC equals to 15 square units. And according to the formula that I presented to you, the area of this triangle FEC will be equal to FE times FC times sinus theta over 2, or we know that FE equals to X, FE equals to X. It is given us in the question that all those sides are equal to each other, therefore it equals to X. If this FAF equals to X, then FE also equals to X. So it is X times X times sine Q over 2. Okay, the area of the big triangle FEC equals to X times X, that is X squared, times sine Q over 2. The area of this triangle, according to the formula that I presented to you, equals to X times X, that is X squared, times sine Q over 2. And the area of the small triangle DBF, will be equal, according to the formula that I presented to you, will be equal to DF times BF times sine P over 2. But DF equals to X and BF also equals to X, so it is X times X, that is actually X squared, times sine the angle that is between those two sides, that is to say it is P, so it is times sine P over 2. Okay, so in total we got that this equality, that the ratio between the areas of those two triangles, triangle EFC and triangle DBF, that equals to 15 over 8. So the area of the big triangle, triangle EFC, equals to x squared times sine q over 2, and the area of triangle DBF equals to x squared times sine p over 2. Here we will move 2 to the numerator here, and we'll move x squared times sine p to the denominator of this expression, and we'll get that 15 over 8 equals to 2x squared times sine q over 2x squared times sine p. Okay, so here two x squared over 2x squared is 1, so 2x squared is cancelled. So in total, what is left here is 15 over 8 is equals to sine cube over sine p. Okay, 15 over 8 equals to sine cube over sine p. Okay, again I write it here, that the equality that we have is sine q over sine p equals to 15 over 8 okay, sine q over sine p equals to 15 over 8, but we have already found out that, according to equation number 2, that q plus p equals to 120 degrees. Q plus p equals to 120 degrees, and we will subtract p from equation number 2, and we will get that q equals to 120 degrees minus p. Okay, so here we can substitute q by 120 degrees minus p. So we will do it now. Instead of sine q, we will write down that sine 120 degrees minus p, that equals to q. So sine 120 degrees minus p over sine p equals to 15 over 8. Okay, we got to the equality that states that sine 120 degrees minus p over sine p equals to 15 over 8. In the next step, I will present to you a new trigonometric identity for the expression sine 120 degrees minus p. Actually, we will calculate the value of sine 120 degrees minus p according to the following trigonometric identity. The identity of sine a minus b actually it equals to sine a cosine b minus sine b cosine A. Okay, so we'll use this trigonometric identity in order to calculate the value of sine 120 degrees minus p. According to this trigonometric identity, the value of sine 120 degrees minus p will be equal to sine 120 degrees times cosine p minus sine p times cosine 120 degrees. Okay, so this is the value of sine 180 degrees minus p. Actually, it equals to sine 120 degrees minus p equals to sine 120 degrees is actually root 3 over 2 times cosine p minus sine p times cosine 120 degrees is minus 1 over 2, and minus times minus is plus, so we will get that sine 120 degrees minus p equals to root 3 over 2 times cosine p plus minus times minus is plus, so it is plus 1 over 2 times sine p. Okay, actually that is the value of sine 120 degrees minus p. Okay, but our original equality was that sine 120 degrees minus p over sine p equals to 15 over 8. So that was our original identity. Here we will substitute sine 120 degrees minus p to the value that it is equal according to the trigonometric identity. We found out that sine 120 degrees minus p equals to root 3 over 2 times cosine p, and we must divide it by sine p according to our equality. We divide it by sine p plus 1 over 2 sine p over sine p. All equals to 15 over 8. Okay, actually we substituted sine 120 degrees minus p to this expression, that it is actually equals to this expression according to the trigonometric identity of sine a minus b, and here we divided it by sine p, and all equals to 15 over 8. So here cosine p over sine p is cotangent p. So we have here root 3 over 2 times cotangent P plus sine P over sine P is 1, so sine P is cancelled, and we left only with 1 over 2. 1 over 2 is 4 over 8 equals to 15 over 8. Okay. We have trigonometric identity that states that cotangent P equals to 1 over tangent P. Okay. Cotangent P equals to 1 over tangent P. So here we will substitute cotangent P in this equality by 1 over tangent P. We will get that root 3 over 2 times tangent P plus 4 over 8 equals to 15 over 8. Okay. So here we will subtract 4 over 8 from this equality. We will get that root 3 over 2 times tangent P equals to 15 over 8 minus 4 over 8. Here 15 over 8 minus 4 over 8 is 11 over 8, so I'll write it down. So root 3 over 2 times tangent P equals to 11 over 8. So here we will multiply this equality by 2 and then we will divide it by root 3 in order to get the value of tangent P. We will get that tangent P equals to 11 times 2 actually here cotangent P is 1 over tangent P, so we add tangent P, we have cotangent P in the numerator, so here tangent P will be in the denominator, so it is actually tangent P. Here it is actually also tangent P is in the denominator, so also here tangent P is in the denominator, so here we will multiply this equality by tangent p in order to find out the value of tangent p. Here tangent p is in the denominator, so we will get that root 3 over 2 equals to 11 over 8 times tangent p. So here we will multiply this equality by 8 and then we will divide it by 11, and we will get that tangent p equals to root 3 over 2 times 8 over 11. Okay. So we got this equality, the tangent p equals to root 3 over 2 times 8 over 11. Actually 4 over 8, 8 over 2 is 4. 8 over 2 is 4, so I'll write it down. Four times root 3 over 11 equals to tangent p. So we found out that tangent p equals to 4 times root 3 over 11. But you know that the tangent p, the function tangent p, is actually expresses the relationship between the sides of a right triangle. Therefore, if we have a right triangle, and we know that this angle is angle P, if this side is 4 times root 3 and this side is 11, then this triangle expresses that the value of tangent p equals to 4 times root 3 over 11. Okay, here in this triangle, tangent p equals to 4 times root 3 over 11, exactly the equality that we have. So this triangle actually expresses correctly this equality. So here we will calculate the value of the hypotenuse, the size of the hypotenuse, in order to get the value of sine p. So the hypotenuse in a right triangle, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So 4 times root 3 square plus 11 square equals to the square of the hypotenuse. But we want to find out the hypotenuse itself and not the square of the hypotenuse. So if we take a root out of the square of the hypotenuse, that is this expression, we will get the value of the hypotenuse itself. So the root of this expression will be equal to the size of the hypotenuse itself. Okay? So and here 4 times root 3 square is 48, 11 square is 121, 48 plus 121 is 169, and the root of 169 is 13. So here sinus P will be equal to the angle that is in front of angle P, that is 4 times root 3 over the size of the hypotenuse, that is 13. So we found out that sine P equals to 4 times root 3 over 13. So in the next step we will calculate again the area of triangle BDF according to the formula that I presented to you. The area of triangle BDF will be equal to x times sine P over 2. Again, the area of triangle BDF, this triangle, equals to x squared times sine P over 2. Okay, that is the area of this triangle, x squared times sine P over 2. But we have already found out that sine P equals to 4 times root 3 over 13, so we can substitute sine P in this equality by 4 times root 3 over 13. And we also know that the area of triangle BDF equals to 8 square units, so 8 equals to x squared over 2, and we will substitute sine P by 4 times root 3 over 13, 4 times root 3 over 13. Here we have 4 over 2 is 2, so in total we will get that 8 equals to x squared times 2 times root 3 over 13. Here we can divide this equality by 2, and we will get that 4 equals to x squared root 3 over 13. So here we will multiply this equality by 13, and then we will divide it by root 3. 13 times 4 is 52, and then we will divide it by root 3, so x squared will be equal to 52 over root 52 over root 3. X squared equals to 52 over root 3. And the area of the equilateral triangle DFC equals to, according to the formula that I presented to you, equals to x times sine 60 over 2. So it is x squared times sine 60 is root 3 over 2, and root 3 over 2 over 2 is root 3 over 4. Root 3 over 4 times x squared equals to the area of the equilateral triangle DFE. Again, the area of the equilateral triangle DFE, this green triangle, equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over root 3, so we can substitute x squared in this equality by 52 over root 3. And we will find out that the area of triangle DFE equals to 52 over root 3 times root 3 over 4. Here root 3 over root 3 is 1, so root 3 is cancelled, and 52 over 4 is 13. So we found out that the area of the equilateral triangle DFE equals to 13 square units. So the area of this triangle DFE equals to 13 square units. So the area of the quadrilateral BDEC will be equal to the sum of the areas of those three triangles, the area of triangle BDF plus the area of triangle DFE plus the area of triangle FEC. Okay, so the area of quadrilateral BDEC equals to the area of triangle BDF, that is 8 square units, plus the area of triangle DFE, that is 13 square units, plus the area of triangle FEC, that is 15 square units. So in total, the area of triangle, the area of quadrilateral BDEC equals to 8 plus 13 is 21, and 21 plus 15 is 36. Okay, so the area of quadrilateral BDEC equals to 36 square units, but we already found out that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. Okay. So from this equality we can derive that 3 times the area of triangle ADE equals to 36 square units. Okay, 3 times the area of triangle ADE equals to 36 square units. So here we will divide this equality by 3 and we'll get the area of triangle ADE. The area of triangle ADE equals to 36 over 3 is 12 square units, and the area of the green shape or green quadrilateral equals to the area of triangle ADE, that is 12 square units, plus the area of the equilateral triangle DFE, that is 13 square units. Again, the area of the square shape ADFE equals to the area of triangle AD, that is 12 square units, plus the area of the equilateral triangle DFE, that is 13 square units. So 12 plus 13 is 25. So the area of quadrilateral ADFE equals to 25 square units. Again, the area of the green shape of quadrilateral ADFE equals to 25 square units. The area of this green shape equals to 25 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of quadrilateral ADFE, the green shape, and we know that angle BAC of triangle ABC equals to 60 degrees, and we also know that BF equals to CF equals to DF equals to EF, and we also know that triangle DBF equals to 8 square units and triangle FEC equals to 15 square units, and we want to find out the area of the green shape of quadrilateral ADFE. Okay. We know that the sum of the angles in any triangle equals to 180 degrees. Therefore, the sum of the angles in triangle ABC equals to 180 degrees. We defined angle ABC as B and angle ACB as C, and we know that the sum of the angles in triangle ABC equals to 180 degrees. That is to say 60 degrees plus angle B plus angle C must be equal to 180 degrees, okay? 60 degrees plus angle B plus angle C must be equal to 180 degrees. Oh, we subtracted 60 degrees from this equality and we got that B plus C equals to 120 degrees. And we have rule number 1 that states that in front of equal sides in the triangle there are equal angles. So in triangle BDF, side BF equals to side DF. Therefore, according to rule number 1, we know that in front of side DF we have angle B, so in front of side BF we have angle DBF. According to rule number 1, those two angles that are located in front of equal sides in triangle BDF also will be equal to each other. That is to say, if this angle is B, this angle must be equal also to B, because those two angles are equal to each other. So this angle also equals to B. Angle DBF equals to B. And the same thing is true in triangle FEC. We have side FC that equals to side FE, and in front of side FE we have angle C. So in front of FC we must have the same angle, angle C, because those two angles are located in front of equal sides, therefore they must be equal to each other. So if this angle is C, this angle must be equal also to C. Okay, then we define the angle DFC as P and angle EFC as Q, and we expressed angle P by B and angle Q by C. According to the rule that says that the sum of the angles in any triangle is equals to 180 degrees, then in triangle BDC, B plus B plus P equals to 180 degrees. Okay, so or in other words, 2B plus P will be equal to 180 degrees. We subtracted 2B from this equality and we got that P equals to 180 degrees minus 2B. And then we also note that the sum of the angles in triangle FEC equals to 180 degrees. So C plus Q equals to 180 degrees, or Q plus 2C equals to 180 degrees. We subtracted 2C from this equality and we got that Q equals to 180 degrees minus 2C, and we already found out that P equals also to 180 degrees minus C. So we added Q to P and we found out that Q plus P equals to we did this calculation and we found out that B plus C equals to 120 degrees. We have already found out that B plus C equals to 120 degrees, and we actually found out that P plus Q equals to 120 degrees and B plus C also equals to 120 to 120 degrees, and then we calculated the size of this angle DFE, according to rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. We know that BC is a straight line because BC is one of the sides of triangle ABC, therefore BC is a straight line. And we have rule number 2 that states that the sum of the angles on a straight line is equal to 120 degrees. So if we focus on point F on the straight line BC, P plus Q plus angle DFE must be equal to 180 degrees. Again, P plus Q plus angle DFC must be equal to 180 degrees according to rule number 2. Okay? From the equality that I presented to you, we found that angle DFC equals to 60 degrees, and then we connected points D and E together by a straight line, and we focused on triangle DFE. On triangle DFE, we know that the sum of the angles is equal to 180 degrees, and also we know that side DF on triangle DFE equals to side FE, so those two sides are equal to each other. So according to rule number 2 that states that in front of equal angles, according to rule number 1 that says that in front of equal angles there are equal sides, those two sides must be equal to each other. So if this angle is y, this angle must be also equal to y. So, and we also know that the sum of the angles in any triangle equals to 180 degrees, so y plus 60 degrees must be equal to 180 degrees, or 60 degrees plus 2y must be equal to 180 degrees according to the rule that the sum of the angles in any triangle equals to 180 degrees. So from this equality we found that y equals to 60 degrees. So all the angles in triangle DFE equal to 60 degrees. So triangle DFE is an equilateral triangle. Okay? And then we found the sizes of those two angles in triangle ADE according to rule number 2 that states that the sum of the angles in a straight line is equal to 180 degrees, and we know that AB is one of the sides of triangle ABC, therefore AB is a straight line. So we can implement rule number 2 on the straight line DB. At point B we know that B plus 60 degrees plus C equals to 180 degrees. B plus 60 degrees plus angle ADE equals to 180 degrees according to rule number 2. And from this equality we found out that angle ADE equals to C. Okay, and then we repeated on the same process on AC. We know that AC is one of the sides of triangle ABC, therefore it is a straight line, and we know that the sum of the angles on a straight line equals to 180 degrees. So if we focus on point E, B plus 60 degrees plus angle, C plus 60 degrees plus angle AED must be equal to 180 degrees. Okay, or C plus 60 degrees plus angle AED equals to 180 degrees. Okay, on the straight line AC, angle C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2. From this equation we found out that angle AED equals to B. So this angle AED equals to B and angle ADC equals to C. So then we proved that triangle ADE is similar to triangle ABC. And we have rule number 4 that states that the ratio between the areas of similar triangles is equal to the ratio of the square ratio of the corresponding sides. Again, the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. That is to say, in our drawing, we have triangle ADE that is similar to triangle ABE. Therefore, the ratio between the area of triangle ABC to the area of triangle ADE equals to the square ratio of their corresponding sides. And their corresponding sides are BC and DE. Therefore, it equals to the square ratio of their corresponding sides. That is to say, it equals to BC square over DE square. Okay? And then BC equals to 2x, so BC square is 2x square, and DE equals to x, so DE is x square. So we found that the ratio between the area of triangle ABC to the area of triangle AD equals to 4, or triangle ABC equals 4 is 4 times bigger than triangle ADE, and the area of triangle, the area of quadrilateral VDEC equals to the area of triangle ABC minus the area of triangle ADE. Okay, the area of quadrilateral VDEC equals to the area of triangle ABC minus the area of triangle ADE. But we know that the area of triangle ABC equals 4 times the area of triangle ADE, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE. So we get here that 4 times the area of triangle ADE minus 1 times the area of triangle ADE equals to 3 times the area of triangle ADE, or the area of quadrilateral DBEC equals to 3 times the area of triangle of quadrilateral DBCE. Okay. Then I presented to you a new formula in order to calculate the area of any triangle. The area of any triangle equals to A times B times sine theta over 2. We will use this formula in order to calculate the areas of triangle FEC and the area of triangle BDF. We know that the ratio between the area of triangle FEC to the area of triangle BDF equals to 15 over 8. So 15 is the area of the big triangle, and the area of the big triangle, according to the formula that I presented to you, equals to x times sine q over 2. X times sine q over 2. And the area of the small triangle, according to the formula that I presented to you, equals to x times sine p over 2, or x squared times sine p over 2. Okay, so we found out that sine q over sine p equals to 15 over 8. Okay, sine q over sine p equals to 15 over 8. We have already found out that q plus p equals to 120 degrees. From this equation, we will subtract p from this equation number 2. We will get that q equals to 120 degrees minus p. So we can substitute q in this equality by 120 degrees minus p. So we substituted q by 120 degrees 120 degrees minus P, and we found out that sine 120 degrees minus P over sine P equals to 15 over 8. Then I presented to you a new trigonometric identity in order to calculate the value of sine 120 degrees minus P. So the trigonometric identity states that sine A minus B equals to sine A times cosine B minus sine B times cosine A. So we calculated the value of sine 120 degrees minus P according to this trigonometric identity, and we found out that by solving the trigonometric identity that states that sine 120 degrees minus P over sine P equals to 15 over 8, we found from the trigonometric identity that I mentioned, we found that tangent P equals to 4 times root 3 over 11. Okay? And from tangent P we found that sine P equals to 4 times root 3 over 13, and we calculated the area of the equilateral triangle DFE, and we know that the area of the equilateral triangle equals to x squared times sine P over 2. That is the area of the equilateral triangle VEF, and we found out that the area of the equilateral triangle DFE equals to 13 square units. After we found out that the area of the equilateral triangle equals to 13 square units, then you can see from the drawing that the area of quadrilateral VDEC equals to 8 plus 13 plus 15, that is 36 square units. So the area of quadrilateral VDEC equals to 36 square units. But we also know that the area of quadrilateral VDEC equals to 3 times the area of triangle ADE. So from this equality, we can derive that 3 times the area of triangle ADE equals to 36. And if we divide this equality by 3, we will get that the area of triangle ADE equals to 12 square units. Okay, so the area of the green shape is the sum of the areas of those two triangles that are also green. That is to say, it equals to the area ADE, that is 12 square units, plus the area of the equilateral triangle DFE, that is 13 square units. So in total, the area of the green shape equals to 25 square units. So the area of quadrilateral ADFE equals to 25 square units. The area of the green shape of quadrilateral ADEF equals to 25 square units. Okay, thank you very much.